Hello, and welcome to this presentation, Understanding Power Supplies, Remote Sense. In this short presentation, we'll explain how Remote Sense is used in benchtop DC power supplies. When a benchtop power supply user enters a voltage, they're often entering the voltage that they want to be present at the load. For example, if we wanted 5 volts across our load, we would connect it to our power supply leads and configure the supply to output 5 volts. However, the power supply lead cables will reduce the voltage seen by the load because these leads have a non-zero resistance. This resistance increases as the leads become longer and/or thinner. In many cases, lead resistance and the resulting voltage drop can be safely ignored, but this decrease in voltage can become significant when working with higher currents or smaller load resistances. The most common solution to this problem is to enable the supply to measure the output voltage at the load instead of at the output terminals, and this methodology is called Remote Sense. In Remote Sense, an additional set of so-called sense leads are used to measure the voltage as close as possible to the load. These leads are connected to a very high impedance in the supply, meaning that almost no current flows through them, and therefore there's almost no voltage drop in these sense leads. Using the remotely sensed voltage, the supply can then adjust its output to obtain the desired voltage at the load. Here, the supply compensated for the 0.3 volt drop by increasing the output voltage to 5.3 volts. Note that this is an automatic/dynamic process. Once the sense leads have been connected and Remote Sense has been enabled, the power supply will automatically and continuously adjust the output voltage as needed. Let's go through this example again in a little bit more detail. Here, we connect a 0.5 ohm load to the supply and configure the supply to output 5 volts. This is the voltage that we'd like to see at the load. If there were no lead resistance, the current would be 10 amps, and there would be 5 volts across the load. In this example, our leads are 2 meters long, 14 AWG, so each lead has approximately 0.015 ohms of resistance. This means that each lead drops the voltage by 0.15 volts, and therefore the voltage across the load is only 4.7 volts. If we add sense leads, the supply can detect this lower voltage at the load and increase output voltage in order to raise the voltage at the load to the desired 5 volts. Time for a brief summary. The leads connecting a power supply to the load have resistance, and this resistance can reduce the voltage seen by the load. In many cases, this small drop in voltage can be ignored, but it can be significant in the case of small load resistances or high currents. A special technique called Remote Sense can be used to overcome this issue. An additional pair of leads, connected to a high impedance in the supply, are used to measure the voltage directly at the load. Based on this Remote Sense reading, the supply can increase voltage to overcome the voltage drop caused by the supply leads. This process is typically both automatic and dynamic, and requires no user intervention once configured. This concludes our presentation, Understanding Power Supplies, Remote Sense. Thanks for watching.